third part for that chapter 21 on generation of biochemical energy. So ATP is the body's energy transporting molecule. Sometimes we refer it to as the currency for energy. ATP, adenosine triphosphate, has 3 phosphate groups. Anytime you remove one of the phosphate group by hydrolysis, you're going to go through adenosine diphosphate, ADP, and that releases energy. Just here showing you how it happened. You can break down that bond with a water molecule, bond broken hydrolysis, and you go from ATP, and that gives you ADP and releases energy. I'm not asking you to memorize exergonic versus endergonic reaction or the delta G. Just need to know that exergonic releases heat and endergonic actually needs to get heat inside, and that's going to be where you have actually you need energy to go from ADP back to ATP. So showing you here, you get the energy from the food and you're going to go from ADP to making ATP, and then that ATP is broken down back to ADP, losing one phosphate, and that releases energy that is necessary for work. So that's what you have right there. Energy released in exergonic reaction and chemical energy in product of coupled reaction plus heat. Excess energy is released as heat and contributes to also maintaining the body temperature. So the net result of catabolism, which is breaking down things, is the oxidation of food molecule to release energy that will be used for any need we have, from thinking, walking, and maintaining the body function we need to have. So a little bit of a closer look on the citric acid cycle. A series of biochemical reaction breaks down acetyl group to produce energy carried by reducing coenzyme and carbon dioxide. I will not ask you to know all the steps, just want you to memorize that this is what we call the citric acid cycle, also named the tricarboxylic acid cycle, TCA, and as well as the Krebs cycle for the person who first described that cycle. If you look at this is very complex, and I will not ask you to know all the steps. The only thing I would like you to memorize is the rate of the citric acid cycle that is controlled by the body needs for ATP, and it goes with coenzyme. When the body's supply of energy is abundant, NADH is present in excess and it acts as an inhibitor, meaning it's going to stop that reaction. Now the cycle can be reactivated when you need energy, and it can be inhibited when we have enough energy. So the net result of the citric acid cycle, which is what I would like you to memorize, you have here what I call intermediate. Okay, you don't need to memorize the 4 reduced coenzyme molecule, but you need to know you have 3 NADH, 1 FADH2 that will be released and intervene in the last step. Conversion of the acetyl group of 2 carbon dioxide molecule and production of 1 energy-rich molecule that will become ATP per cycle. Now remember, the glucose is first split into 2 pyruvates. Each of those are going to go through kind of a grooming to make 2 acetyl coenzyme A. Each of those goes through the citric acid cycle, which is represented right here. So the bottom line, for 1 glucose molecule, you will have 2 ATP produced by the citric acid cycle, also known as the Krebs cycle.